Well, we're in a chapter section on weighted averages, and what we're going to see here in this chapter section are two types of problems. And they're both word problems, but we're going to be working with mixture problems, and then we're going to work with uniform motion problems. So let's start here with a look at mixture problems. Now, in your textbook suggests that you use a table to help organize your work when it comes to solving mixture problems. I kind of like to use the buckets. I kind of visually see it better this way. And I'm not talking about the kind of buckets shooting a basketball goal. I'm certainly not talking about the kind of buckets where you wad up a piece of paper and throw it in the trash can. But I'm talking about buckets to help me organize my work. So let's take a look at what we got here on the problem. We got Quick Mark has two kinds of nuts. We have pecans that sell for $1.55 per pound. And we have walnuts that sell for $1.95 per pound. How many pounds of walnuts must be added to 15 pounds of pecans to make a mixture that sells for $1.75 per pound? Well, let's first kind of label what our buckets are. And I'm going to say that this first bucket is for pecans. We'll just call P. And my second bucket is walnuts. And then my third is the mixture, whatever the mixture is here. Now, what else do we know? Well, we know that pecans sell for $1.55 a pound. And we know that walnuts sell for $1.95 a pound. So there's my $1.55 a pound for my pecans. Here's $1.95 for my walnuts. And I want to make a mixture that sells for $1.75. And so the question is how many pounds do I need per mixture? Well, we're given a little bit more information here because we're asked here how many pounds of walnuts must be added to 15 pounds of pecans. So in the pecan bucket, I can put 15 pounds. Now in the walnuts, that's what they're asking us. So I'm going to set that as my variable, and I'm going to call the number of pounds for walnuts X. And in my mixture, well, I don't have a total number of pounds. All I'm asked to do is find out what it's going to take to be able to sell it for $1.75 a pound. And so my number of pounds in my mixture is going to be whatever is going to be 15 plus whatever pounds of walnuts I need to get to this $1.75 cost. Now that I got my buckets kind of labeled here, I can set up my equation. All right, so I can then say that I got $1.55 of pecans, and I've got 15 pounds of those. And I'm going to add walnuts at X pounds times $1.95. So I'm going to say that's $1.95 X. And that's going to equal my total cost of my mixture that I'm looking for, which is going to contain the 15 pounds of pecans plus ever how many walnuts it's going to take to get my cost to $1.75. Well, now I can just mathematically put this equation together. Oh, let's see here. When I multiply 15 times $1.55, I'm going to get 23.25 plus, well, I still got $1.95x. I'm trying to find x equals, I get to the right side. Now I'm going to have to distribute this $1.75 times everything inside that parentheses. In other words, I'm going to multiply $1.75 times 15. And when I do, that's going to come to 26.25. But I also got to multiply, because I'm distributing, I got to multiply the $1.75 times the x. So I now got $1.75x. All right, so now I'm going to look to combine like terms. And I'm going to put my x's over here on the left, and I'm going to put my constants over here on the right. So if I'm going to get my x's on the left, I want to subtract $1.75 from both sides, and I want to subtract 23.25 from both sides. Now, when I subtract $1.75 over here, it's going to cancel. When I do it here, it's going to leave me with 0.20x. And when I subtract 23.25 from the left side, it's going to cancel here. And over here, I'm going to be left with just 3. I'm going to go ahead and put the zeros in since we're dealing with decimals over here. So now I got 0.20x equals 3. Well, I'm going to divide both sides by 20, or 0.20, excuse me. Boy, if I did it by 20, I'd mess up. 0.20, and when I do, that's going to give me x equals 15. So what does that tell me? Well, that says that if I add 15 pounds, I'm going to substitute right here, I'm going to have 15 pounds of walnuts at $1.95 that I'm going to add to 15 pounds of pecans at $1.55, and I would end up with a total mixture of 30 pounds in this case, but my mixture would cost $1.75, and that's what I was trying to find out. How many pounds of walnuts do I need to add to 15 pounds of pecans selling at $1.55 to get a mixture that sells for $1.75 if the walnuts are $1.95? Well, it just happened to work out. It's the same number of pounds, 15. There you go. There's a mixture problem. It's not too bad. Well, let's look at another word problem. So here we got Sergio. Sergio sells a mixture of Virginia peanuts and Spanish peanuts for $3.40 per pound. Now I'm going to pause right here. I'm going to go ahead. I know I got Virginia peanuts. I'm going to say VA for short. And I got some Spanish peanuts. And I'm going to have a mixture. All right, let's go back to this first sentence again. He sells a mixture of Virginia peanuts. I got a bucket for it. And Spanish peanuts. I got a bucket for it. And I've got a bucket for the mixture, which it tells me that he sells that for $3.40 a pound, $3.40. Well, that irritates me. Let's redo this. We got Virginia, we got Spanish, we got the mix, and we got $3.40. Okay, a little bit better. All right, so to make the mixture, he uses Virginia peanuts that cost $3.50 a pound. So I can put $3.50 in the Virginia bucket. And he uses Spanish peanuts that cost $3 a pound. So I can use $3. I can put $3, 3, that's a sorry 3, but nonetheless, maybe that's a little better. $3 a pound on the Spanish peanuts. And goes on to say he mixes 10 pounds at a time. So what that means is this mixture is going to contain 10 pounds. Now, even though both of these that we're looking at here are mixture problems, there's a little bit of difference in this one and from the previous one. In the previous one, it didn't matter how many pounds of nuts we had. We just wanted a cost of $1.75. And we had one group that sold at $1.95, and another, the pecans sold at $1.95, and the walnuts sold for $1.70, $1.55, didn't it? Yeah, $1.55. But now we know how many pounds we want in the total mix. Now, we see here we got two questions. How many pounds of Virginia peanuts does he use? Well, I'm going to say that if he uses, I'm going to give that my variable X. How many pounds of Virginia peanuts does he use? So we're going to have X number. And if I got 10 pounds in the mix, and I'm going to use X number of pounds of Virginia peanuts, that means that my Spanish peanuts have got to be 10 minus X. And why is it 10 minus X? Because I got 10 total pounds in this mix. So ever how many pounds of Virginia peanuts I use, well, I take 10 less that, and that tells me how many pounds of Spanish peanuts I use. Now, I'm ready to write my equation. And so I'm just simply going to take what my buckets tell me. And I've got 350X plus 3 times 10 minus X equals 3 $3.40 times 10. All I'm doing is just putting in what my buckets tell me for each piece of my equation. 350x, 3 times 10 minus x, and 340 times 10. Okay, well, I'm still going to be left with the 350x over here for the time being. But now, on the second set of terms, I'm going to have to distribute the $3 times the 10 and the minus x. Well, when I distribute the 3 times the 10, I'm going to end up with 30. And when I distribute the 3 to the minus x, I'm going to end up with 3. And I'll go ahead and put the decimals in, don't have to. 3x equals, and now I'm going to multiply the 340 times the 10, which would give me 34. All right, so I'm going to combine my like terms. Well, fortunately, my x's, which I'm going to leave here on the left, all I've got to do is take 350 and subtract $3 from it, and that's going to give me 0.50x. But I am going to go through here and subtract 30 from both sides. So when I do, that's going to cancel right here, but it's going to leave me with 4 on the right side. Now, all I've got to do is divide the 0.5 into the 4 to isolate the x, and I'm going to get x equals 8. So let's go to what it asked me. How many pounds of Virginia peanuts did he use? Well, x equals 8, and so he used 8 pounds of Virginia peanuts. Now the second question, how many pounds of Spanish peanuts does he use? Well, right here I've just got 10 minus x. So to figure out the number of pounds of Spanish peanuts he uses, I just substitute the 8 in for x, and 10 minus 8 is going to equal 2. And 8 plus 2 equals 10. That's my total mixture. That's my total bag. The weight of my total bag is 10 pounds. And so how many pounds of Virginia peanuts does he use? 8. And how many pounds of Spanish peanuts does he use? 2. And that gives him a mixture of 10 pounds at $3.40 a pound. Hey, this is a lot of fun. Now let's have you work on a word problem. So here's our problem. A nursery sells Kentucky bluegrass seed for $5.75 per pound and tall fescue for $4.50 per pound. And it goes on to say, let K represent the amount of Kentucky bluegrass seed. In other words, K is going to be the variable. And the nursery uses 5 pounds of mixture. So, 4 things you're asked to do. I'm going to say complete your buckets, write an equation to represent the problem. You're going to get to the equation from your buckets, and then you're going to find out how many pounds of bluegrass seed the nursery uses in a 5-pound mixture. And then from that, you can then determine how much tall fescue does the nursery use in 5 pounds of the mixture. So you're going to have a bucket for the Kentucky bluegrass, a bucket for the tall fescue, and you're going to have a bucket for the mixture. And in this case, you know that there's 5 pounds of the mixture. Now I'm going to give you just a few moments, leave this up here. If you're online, I expect you to give me an answer in either a comment or a reply. And if we're in class, well, then I'm expecting you to work the problem there in class. But I'm going to leave this up for just a moment so that you can make sure that you've got the relevant information down and start working on completing your buckets, writing the equation, solving for the number of Kentucky bluegrass seed is used in a 5-pound mixture, as well as the tall fescue. I'll be right back in a bit. In fact, while you're working on that, I'm going to eat a piece of pumpkin pie. It's pretty good. Wish you had some, but you don't. Don't you just love Thanksgiving? Well, by now you ought at least have your buckets completed. And if you got your buckets completed, you can write the equation. Looking forward to seeing how you solve it.